All right, so let's take a look at the problems here. Trust me, I've worked them out a little bit so that it won't be horrible going through them. I'm not going to go through all of them. 40. I mean, you know the basic. You've got the basic equations in front of you. What is the capacitance of a capacitor that stores 5? Now, be careful with this micro stuff. 5.5 times 10 to the negative 6. Voltage 8.9. Piece of cake, because you know Q is equal to CV. Shoot, they gave you C. They gave you um, they gave you Q and they gave you V. You got to be careful because you want to say that that's just looking at it. You go, oh, the C must be the capacitance when you're new to this. No, that's your charge Q. What about 43? The electric potential stored in the capacitor of a defibrillator is 76 joules. Oh, this is kind of a nice one. All right, what is the potential difference across the capacitor? All right, well, what would be the best way to approach this? 76, 110 microfarads. Okay, so if you've got, you know that the energy, the electric potential energy stored in there is 76 joules. Well, we've got our two energy equations, right? We've got 1/2 CV squared, or you've got V squared over 2C. All right, so is equal to the energy. All right, so what are they asking though? Just look at what they're asking. They're asking for, they gave us the capacitance. All right, so what is the potential difference? It doesn't really matter which one you pick. It'll work. Just set one of those equations equal to 76 joules and knock yourself out. 44. Two identical, oh, this is kind of fun. Two identical capacitors are store different amounts of energy. Interesting. Capacitor A stores this much. Capacitor B stores this much. Now remember, the C is the same. The voltage across the plates of capacitor B is 12. Find the voltage across the plates of capacitor A. Again, they're identical capacitors, but they store different amounts of so that's one of those. This is one of those problems where you've got to use one equation, use one problem to come up with a value for C to plug into the next one that you might know. So what do we mean by that? So the energy of one. So let's just take a look at the energy of one. So the energy of one is equal to 1/2 C, which is going to be the same, times V1 squared. Okay? And if I'm given the voltage of one of them, then I can figure out what C, this is what I'm saying. So you go 2E1, which is given. C is what I don't know. All right. So you get 2E1 divided by V1 squared. So you find the one that they give you the energy and they give you the voltage, and that is equal to what the capacitance is. Then you plug that capacitance back into E2, because did they give us the different energies? Yeah. They gave us the different energies. You plug that back in, so E2 would equal 1/2 all of this mess times V2 squared. And then you solve for V2. Okay? That's the way you do those. So that's why I like those kind of problems, where you got to pick information from somewhere and get somewhere else. This is kind of a fun one. We might do that one in class as a warm-up. It is just Monday class. And then this one I just did too. All right. Stand by. We'll probably do 45, 48 Monday in class. Okay, I know that first thing, that one like track 5 was kind of crappy, but oh well.